All right, we're in section 1.8, last section of the chapter. All right, and let's put our electronics away. I forgot to do my little scroll. Electronics away. I'm also looking for either goldfish or cheeses. I'm hungry. All right, let's put the computer away, please. All right. Basic area review. We're going to talk about perimeter. What I should have called the word that I should have used on my last homework. Perimeter and area. How do we find the perimeter of any shape? The length of all the, what did you say?
Sides.
Sides, you said another word. Outside. So we're talking about the distance around the outside. Two-dimensional shapes, right? Three-dimensional shapes don't have perimeters. And if we have some kind of shape, some kind of two-dimensional shape, how do we, if we have a picture of it or something, how do we find the perimeter?
Add the length of all the sides.
Just add all the side lengths that are around the outside. So I'm just going to say for shorthand, add all the sides. So on all these shapes, we could write down some kind of formula for the perimeter, but really the bottom line is add up all the sides that make up the outside. That's all we have to do. All right, let's talk about some specific shapes. Square. What is special about a square? How do we know we have a square? What do we have to have? All sides are congruent. Okay, sounds good. So here's my square. Let me move that a little bit. There's my square. So all the sides are congruent. I'm going to call the side length S for side. What about these angles? All right angles are all 90-degree angles, so all these are 90-degree angles. Does anybody know there's a special kind of shape where it has where all the side lengths are the same, but not all the angles are 90-degree angles? What did you say? Parallelogram. So parallelogram. It's a special kind of parallelogram. It is a parallelogram. We give it, if all the sides are the same, we call it a rhombus. And we'll talk about those later. Square. So all the sides are the same, 90-degree angles. How do we find the area of this square? Base times height, length times width. So if the length and the width are S, how do we write that? S times S. What's another way of writing S times S? S squared. And since we're talking about area, our units are going to be units squared. So square inches, square miles, square meters, something like that. And if we wanted to write a formula for the perimeter, how many of these side lengths do we have? 4. We would write 4S. And all we're doing is adding this 4 times. That's what this means. And our units for perimeter are always lengths, so it's going to be units. Inches, meters, miles. Okay. Let me rewrite my notes. All right, so there's our square. Rectangle. What makes a rectangle special? What is it? What about the sides? 2 sets of equal sides. So we have 4 sides total. I was hoping somebody would tell me that what was special was it was a family of angles that got in a car accident.
Oh, I get it.
Rectangle. Didn't I tell that joke before? But the other family was all right. And these angles again? Right? And let's call this length B and this H. How do we find the area of a rectangle? Length times width or base times height. B times H. And we have units squared. Perimeter, add up all the sides. And it's going to be in units, inches, meters, some kind of length. How about a triangle? What makes a triangle special? Has 3 sides. So let's draw a triangle, some kind of triangle here. And we can have all kinds of different triangles. What's our area formula for a triangle? 1/2 the base times the height, which is the same as saying base times height divided by 2. Dividing by 2 and multiplying by 1/2 are the same thing. Units squared. So let me draw in, this would be our base and our height. The way we find our height has to go from one vertex and make a 90-degree angle to the other side. And our perimeter, add all sides. And it's going to be in length units, inches, miles, light years. All right, we good there? Now we're going to talk about a little more interesting shape. A little more interesting things happen with the next one. A circle. And what makes a circle special?
No longer a perimeter.
Doesn't have a perimeter anymore. Whoops. I'm going to do that. All right, so I'm going to draw in a couple of things on my circle. So what is this? What is the segment that goes all the way across through the center? Diameter. So the diameter goes all the way across through the center, and the other one is the radius. Dia means across. Meter means to measure. So diameter means to measure across. All right. So our area of a circle. Remember? Pi r squared. And what do we call the distance around instead of the perimeter on a circle? Circumference. You remember how to find the circumference of a circle? Pi times the diameter. And what's another way of saying the diameter? How's the diameter related to the radius? Twice the radius, so I can say 2 pi r. 2 times r is the same as b. And we have units. So those are our basic area formulas. I want to do one example with the circle just to talk about it different, kind of the way that the problem will be asked in your book. So we're familiar with that. And then a couple of other examples that have to do with looking at the shapes in a little different way. So we good with our formulas? Okay, let's look at an example. Here's my circle. And I'm going to say this is 24 meters. And we want the area and circumference. So our area, pi times what squared? 12 squared. This is the diameter, so we want 12 squared. 12 squared is 144. So I'm going to write the answer like this first. If the question asks for an exact answer, or an answer in terms of pi, what they're asking you to do is multiply, do all the things with the numbers, but don't multiply pi at the end. So you just write the number times pi. So the exact answer for the area of this circle would be 144 pi square meters. And the reason that's exact is we know that pi is a decimal that goes on forever. It doesn't ever stop, and it doesn't ever keep repeating the same set of digits over and over and over again. The symbol pi contains all those infinite decimals. When you put it in your calculator, it rounds it off eventually. So you're getting an approximate answer. So this is what we call the exact answer. We want the approximate answer, then we multiply this together. So we say it's approximately equal to, and we'll calculate that, 144 pi. 452 point what? 16 square meters. And this would be the approximate answer. So if they ask for the exact answer, you would leave your pi in there and you just multiply and do whatever with the numbers and leave pi in your answer. All right, circumference. We have the diameter here, so it's going to be 24 pi meters. That would be my exact answer, or the approximate answer. 24 times pi gives me 0.36 meters. So this would be the approximate answer. So the first answer is our exact answer, or our answer in terms of pi, and this is our approximate answer. And the book will ask the will ask the question in both ways. They'll say, find the area of the circle in terms of pi. They mean this. Find the area of the circle rounded to 2 decimal places. They mean this. Find the exact area of the circle. They mean this. Okay, questions there? All right. What if we had coordinates? So let's say we have the vertices of a triangle, and we have these coordinates. -4, 3, -4, -5, and 2, -5. And we want the area and perimeter. What are we going to do? Plot it. Let's plot it first. That's a good idea. I like that idea. So here's I'll just do a little plot. Draw a little graph here. And let's see what we're looking at. So I'm going to just label my there are my points, so I'm going to go over -4 and up 1, 2, 3. So I get a point there. -4, -5. So -4, and I'm going to go down 5. Thank you. And then 2 and -5. So there are my vertices of my triangle, and let's connect those. Well, there's what we're looking at. And if I would have drawn this perfectly, because we're at -5 our y-coordinate and -5 our y-coordinate there, this should be perfectly straight, parallel to the x-axis, and this goes straight up and down, so that's a 90-degree angle. So what is the length of this side? 8. From -5 to 3 is 8 units. What's the length of this side? 6. -4 to 2 is 6 units. Well, now we can find our area, right? Our area is, what's the base? 6. What's the height? 8 divided by 2. 6 times 8 is 48 divided by 2 is 24 units squared, whatever the units are. Well, now we need the perimeter. So we need to figure out this side. What can we do to figure out that side? We could use a Pythagorean theorem. We know two sides of a right triangle. And if it weren't a right triangle, what else could I do to find the length of that side? And here are my hints. I have 2 points. The square root, we're finding the distance between those 2 points. We can use a distance formula. So if it's not a right triangle, we can always use a distance formula. So let's use a distance formula since we just practiced that. So I'm going to call this, we'll find the distance between those 2 points. The distance equals, let's label them, x1, y1, x2, y2. Distance equals the square root of x2 minus x1. And we're going to square that. Plus y2, -5, minus y1, 3. Square that. -2 minus -4, 6. So we have 6 squared plus -5 minus 3, -8 squared. And we remember that we never end up with squares or with negative numbers under our square root. So we have 36 plus 64. 36 plus 64 is 100. And the square root of 100 is 10. So we figured out the length of this side is 10 units. So now our perimeter is 8 plus 6 plus 10 equals 24 units. So when we have points in the coordinate plane, we can always find the distance between them, the length of a side, by using the distance formula. And it's fine that our area and our perimeter turn out the same. That can happen sometimes. Doesn't always happen, but it can. And this is 24 square units, and this is just 24 units. 24 square inches and 24 inches. All right, we good there? Okay. One last thing. Irregular shapes. If we have irregular shapes, so what we're going to do is divide them into regular shapes. And by regular shapes, I mean shapes that we know how to deal with. So all I want to do here is just show you an example. See if I can draw a decent picture this time. Last time I drew this picture didn't turn out great. All right, that way. Okay, that's not terrible. And I'm going to do this. And I'm going to say these are in meters. All right, so this isn't a rectangle, this isn't a square, this is an irregular shape. Let's divide it into regular shapes. Where would be a good place to divide this? Right here at the 8 part. So I'm going to divide it like so. Like that. And now how big is this rectangle? 12 by 16. And how big is this little piece here? 8 by 8, right? This says these are all congruent. So that's 8 and that's 8. So this is 8 by 8. So we just divided the shape into 2 pieces. And if we wanted the area is 12 times 16 plus, we're going to add those 2 together, 8 by 8. 12 times 16 is 192 plus 64, and we get 256 square meters. And if we wanted the perimeter, I would just add all these pieces together. 20 plus 16 plus 12 plus 8 plus 8 plus 8. That would give me my perimeter. So that's all we need to do for irregular shapes. Just divide them into regular ones and use what we already know. Climb the tree and grab that coconut. Climb up the other tree. All right, questions? Anybody have a question? Okay, homework. Oh, and then we'll go over our homework from last time. Okay, there you go.